Hello, welcome to Chapter 6, Homework Questions 110 to 115. Question 110. Consumer Report magazine collected data for the fuel efficiency of cars in miles per gallon compared to the weight in thousands of pounds. The regression model below was created. Y is equal to 49 minus 8.4x, and then the R value is negative 0.93. So we're answering two questions here. The first one is interpret what the R squared is in context. So we need to figure out what R squared is, and since we're not really doing this on the graphing calculator, we just need to take the R value of negative 0.903 and square that on our calculator to figure out what R squared is. And we get a value of 0.815409, and we can round that. And we'll change it to a percent as well. We'll do 81.5%. Okay. And so we also need to interpret what that means in context. So 81.5%, you have to know what your independent and dependent variables are. So you have the fuel efficiency of cars in miles per gallon compared to the weight in thousands of pounds. And so the fuel efficiency of the cars, the miles per gallon, depends on the weight of the car. So this would be thousands of pounds would be independent variable, your weight, and then your dependent would be the miles per gallon of the car. So we know that 81.5% of the variability in fuel efficiency can be explained by a linear relationship with weight. All right, question B, it says interpret the slope in context. So we have the slope as negative 8.4. All right, and so slope is the change of y or the change of x. So we have the change of y, which is the miles per gallon, over the change of x, which is your weight. Now that is in thousands of pounds. So this 8.4 over 1 would represent 1,000 pounds. So it is a negative slope, so we do know we have a negative association. And in terms of what the negative 8.4 represents, it would represent an increase of 1,000 pounds in weight is expected to decrease the fuel efficiency of 8.4 miles per gallon. So once again, when this is negative 8.4 over 1, that 1, because the independent variable is in thousands of pounds, it's going to increase 1,000 pounds in weight. Or an increase in 1,000 pounds of weight is expected to decrease, though, negative 8.4, so that's a decrease in the fuel efficiency by 8.4 miles per gallon. And there's my answer that I wrote down for part B. Question 111. Here are some more news headlines from real observational studies. Determine at least one plausible lurking variable that could explain the cause and effect. Remember, do not argue about the link expressed in the headline. Accept the association is true. Your task is to find the other variables that could be the actual cause or causes. So for the first one, the graveyard shift may be aptly named. Working nights will soon be listed as a likely cancer cause. So we're going to accept it as true that if you're working those night shifts that it could cause cancer. I think this one's a little bit challenging. Maybe one of the things is if you're working nights, maybe you're not getting the appropriate sleep. Maybe you're not eating healthy enough because of the times and things like that. So that was a little challenging, but those are a couple of my suggestions. So on that one, what are some other variables? One of the ones that you could think about is that it could actually be tied to the gender. Men as a group eat more meat, and we know men don't typically live as long as women. So maybe that is actually the cause of the early death. Another possibility depends on what kind of meat they're eating. If it's processed meat, that's not as good for you as other meats. So a couple of different options there as well. And so those are just a couple ideas, and there's obviously other things that you could have wrote down as well. Question 112. For the recursive defined sequence, a sub 1 equals 5, a sub n is equal to negative 2 times the previous term. So on A, list the first 5 terms of the sequence. So we know that the first term is 5. That's what the a sub 1 represents. That's a sub 1. Your next term, which would be a sub 2, is equal to negative 2 times a sub 2 minus 1. Or if you simplify that, the second term is equal to negative 2 times the first term, which we know is 5. So the second term is equal to negative 2 times 5, which would be negative 10. So that's the second term. Now, since it's written as a recursive sequence, each term previous is getting multiplied by negative 2. So negative 10 times negative 2 is 20. 20 times negative 2 is negative 40. Negative 40 times negative 2 is 80. So that would represent the first 5 terms of the sequence using the recursive form. Now on part B, it says write an explicit equation for the sequence. So we need two things. We need the initial, or term 0, and we also need to know what the multiplier is, which we already know that we are multiplying by negative 2 to get to the next term. So we need to work backwards to find what a sub 0 is, and if we're multiplying by negative 2, then we would divide by negative 2 to figure out what the term before is, which would be negative 5/2. So once again, we're going to work backwards here and divide by negative 2 to get the previous term. And so now we have everything we need. So we're going to write this as an explicit equation. So a sub n is equal to the initial, which was the negative 5/2, times negative 2, and then that will be raised to the nth power because it's being multiplied over and over and over again to get to the next term. Question 113. Corin and Leah are working on homework problems that involve arithmetic sequences. Corin wrote down 2, 4, and 3, 5 from one sequence, and Leah wrote 3, 2, and 0, 3 for a different sequence. Find an equation for each sequence. So we'll start with Corin first. She has 2, 4 and 3, 5. And it does say they're arithmetic, which means we are looking at a common difference here. So if we can figure out the slope by taking the change of y or the change of x, and that's 1 over 1 is 1. So we know that to get to the next term, all we're doing is adding 1 each time, but we also need to figure out what that starting value is. And we could do this a couple of ways. One is by using the equation or using a table and working backwards. I'm going to go ahead and just use the equation. 4 equals 1 times 2 plus b, just plugging in the appropriate values for each of the variables. Subtract 2, and b is equal to negative 2. So the sequence for Corin would be t of n is equal to your slope, which would be 1 times x, well, it should be times n because we're using n as a variable, and then minus 2. And that's not, I don't know why that was a negative. I need to go back and fix that. B should be, if I subtract 2, b is equal to positive 2. So it's actually plus 2. So t of n is equal to 1n plus 2. So there's the sequence for Corin. Now if we compare that to Leah, alright, Leah is using the point 3, 2 and 0, 3. Now Leah, actually, we have the initial value on hers because 0, 3 is where it starts. But we still need to find the slope. So we'll do 3 minus 2 and 0 minus 3. So it looks like we get 1 over negative 3. And once again, you can use your y equals mx plus b if you need to, but if you're paying attention, we already have the b value at 0, 3. So we have enough to write the sequence. T of n is equal to negative 1/3 times n. That's what it's going to be changing by, and then we're going to start at 3. So we add 3 to create that sequence. So you need the initial, which is the value at term 0, and then you need to figure out for the arithmetic sequence what you have to add to get to the next term, which is your slope or rate of change. Question 114. Make a table and graph of y equals the quantity 0.5x minus 3 raised to the third power, and then completely describe the graph. So we're going to start by maybe making a table here of x and y values. Okay. And start with some negatives, and then kind of see where that gets us when we plug in these values. So if we're going to plug in these numbers, we're just going to take 0.5, times it by -1, subtract 3, and then cube it. And I would just plug these into my calculator and get the values for y to get a good graph. Now it is cubed. We haven't done a cube in a long time, so we'll have to make sure we get enough points to get the full shape and know what it looks like. So you can see I started to create the table. When I plugged in -1, I got -42, which on my 10 by 10 graph isn't going to fit. And then I plugged in 0 and got a nice number, plugged in 1, got a decimal, plugged in 2, got a nice number. The numbers are getting smaller to fit on my graph. But then, if I'm looking at -1 and 1, I'm getting these decimals, but 0 and 2, I'm getting nice numbers. Well, why is that? Because you are multiplying x by 0.5. If you plug in even numbers, you'll get nicer values, where if you plug in odd numbers, you're going to get decimals. So from here on out, I'm going to only plug in numbers that are even. So 4, 6, 8, 10, and we'll see where that gets us. So there's my full table. I went all the way down till I got to 8, and then 27, went all the way back up. So I went ahead and stopped. I'm going to go ahead and graph the values that we have that fit on the 10 by 10 that I have. So 2, -8, 4, -1, 6, 0, 8, 1, and then 10, 8. So those are the 5 points that fit. So what does this look like? It's going to be a curve. Just trying to connect the points best I can, but it is going to look like that. We did one of these earlier on, but as I said, we haven't really done them in a while. So we want to now go through and kind of completely describe the graph. Remember the list that we created. We want to talk about the shape. We want to talk about, what intercepts or important points we have. Is it increasing, decreasing? So go back and look at that list and write some of those things down, and then I'll kind of create a list to help and see for you to compare. So here's the list I created. I said the graph is curved. The graph is increasing as you work from left to right. So as you work from left to right, the graph continues to get larger, the y value does. The x-intercept is at 6, 0. The y-intercept is at -27, 0, and I used, I need to fix that. It should be 0, -27. Alright, fix that, 0, -27, so I use the table for that. There's no line of symmetry. The domain and range are both all real numbers. There's no max or min values, and it is a function. So that was kind of the list that I created to completely describe the graph. And you should have something pretty similar with each of those. And the last question, 115. Zachary has $718 in his bank account that automatically withdraws $14 every month to pay for his computer service. Christian has $212 in his bank account and deposits $32 each month from his newspaper delivery tips. Assuming they make no other deposits or withdrawals, when will Zachary and Christian have the same amount of money in their bank accounts? So it looks like we need to set up some let statements, and we also need to decide, are we going to set up one equation or two, depending on the information that we have. So right now we're dealing with money in the bank, so we can say, let B or XY, whatever you want to use, but let B equal the amount of money in each bank account. And then the other part is they are depositing or withdrawing each month. So we also need to have a variable for time. So let M equal the time in months. So those are our two variables. We can set up two different equations for each of the different accounts. So for Zach, we have he has $718 in his bank account and withdraws $14 every month. So the amount of money in his bank is $718, but he's going to withdraw or subtract $14 every month. Whereas Christian has $212 in his account and is going to deposit or add $32 per month. Okay, so the way I created it was a system of equations, and now we can use substitution pretty easily to see that this expression and this expression, are the same. And the reason is because we want to know when they have the same amount of money in their accounts. So we know the b values need to be equivalent. So we'll set up the equation. 718 minus 14m is equal to 212 plus 32m. And then we can solve this equation by getting our variables on one side and the constant on the other. So I will add 14m. And if I add 14, that'll be plus 46. Subtract 212. And that'll give us 506. And then we should be able to divide by 46 and figure out how many months that will give us, that will make both their accounts equivalent. And that will be 11 months. So to make sure we answer the question, assuming they make no other deposits, when will their accounts have the same money? So it just wants to know when they'll have the same. It doesn't want to know necessarily how much, so we don't have to answer that part of it. So we know that their accounts will be the same. Zachary and Christian's accounts will be the same after 11 months. And so make sure you answer that question. Where you're saying something about the two accounts will be the same after 11 months. And so that's it for questions 110 to 115.